Hi guys, this is Miss Scott, and today we're going to jump back to chapter 10 and talk about some properties of chords and how we can apply those to set up equations to solve for unknown variables. So before we get into that, here is your bad joke of the day. What do you call a cow that just had a baby? Decaffeinated. Okay, so here is your essential question. How can you tell if two chords in a circle are congruent? So if you'd like to pause the video and jot that down, that would be a good idea. And then go ahead and, while you're at it, jot down these first two definitions. All right, now that you have that written down, there's actually two ways to tell if two chords in a circle are congruent. But before we get into that, we need to know that congruent chords are chords with the same length. And then bisecting arcs, that is a line that cuts an arc into equal length and measure. So if you have a circle, let's see what that looks like. So say you have a circle and then you have a chord that goes through it. So I'm going to make that red. So then say I've got this line that goes through that circle, and then I've got these arrows on the end, and then I have these points here. So what a bisecting arc is going to do is make this and this piece the same length and the same number of degrees. All right, so this would be the bisector, and then these two arcs would be bisected. All right, so the last definition, we're actually just going to draw a picture for this. So go ahead and draw a circle, and then in that circle somewhere draw a chord, which is just a line that goes through that circle, or a segment that is each point is on the edge of the circle. And a perpendicular bisector of that chord is going to be perpendicular to it, first of all. And then it is also going to be cutting it into two congruent pieces. So this line here is what we would call the perpendicular bisector of a chord. All right, so now that we have some understanding of what those terms mean, we are going to look at our first theorem in this section, which tells us that in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. And we'll draw a picture to show you what that looks like. So draw a circle, and then go ahead and draw a chord here, and then another chord over here. So the only way that those two chords are going to be congruent, so if you want this and this to both be the same number of units long, well, it turns out this arc and this arc have to be the same number of degrees. So let's use that to look at an example or two. All right, so what that looks like when we start to solve problems is that, notice I have two tick marks here and two tick marks here. So if this is 128 degrees across from that chord, this also has to be 128 degrees here. So now the only piece that we don't know is z. Well, if we're considering this entire circle, remember the whole circle has to add up to 360 degrees. So we're going to take 128 plus 128 plus 20 plus z, and that has to equal 360 degrees. So if we combine some like terms, this turns out to be 276 plus z is equal to 360. And then if we subtract 276, these will cancel, And we end up with z equals 84 degrees. Okay. All right, so now let's look at an example very similar to that one. If you'd like to pause the video and try this one yourself for some practice, I would encourage that. We're going to move along though, if you don't want to try it yourself. So here they want us to find the measure of angle AC. So that is this arc here. And if we know the arc BC is 110, so they're telling us that from B to C is 110 degrees. But then notice that that's across from this 9. Well, here we also have a chord with a length of 9. So this arc here must also be 110 degrees. So let's call arc AC X, and we know that X plus these other two arcs of 110 and 110 have to equal 360 degrees. Or if we combine like terms, X plus 220 is 360 degrees. So let's get that 220 out of there. And we end up with X equals 140 degrees. All right, so it just, if you know that two chords are the same, they have the same number of degrees on their arc that they create. All right, we're going to look at 3 more theorems, and some of these are a little tricky, so just hang in there. The first one says if one chord is a perpendicular bisector of another chord, then that first chord is a diameter. So let's draw a picture of what that looks like. So here we have a circle, and then let's draw a chord from that point to that point. And it turns out that if you have that chord and another chord bisect each other, so they this chord here, the one in the middle, is a perpendicular bisector of this one. Well, what has to be true then is that this has to go through the center, and then this chord here, this red one, has to be the diameter. That's the only way that a chord can be a perpendicular bisector of another. All right. This next theorem is kind of similar, at least it looks similar. It says if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So again, let's draw ourselves a circle here. And then if we draw a chord in there, so just draw a chord anywhere you want. And if we have that the diameter is perpendicular to that chord, so let's say we've got the diameter here, so we already actually know this is the diameter, so it goes through the center. And if that diameter is perpendicular to a chord, then it does two things. The first thing it does is it bisects the chord. The other thing it does is actually bisect the arc. So like say that this is 5 and this is 5, well then these would be the same number of degrees. So maybe this is 60 degrees and this is 60 degrees. All right, so kind of interesting there. And our last theorem is going to be one that we use in a couple of examples here. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. And again, we will draw a picture of what that looks like. So draw yourself a circle. And then say we've got a chord here and another chord here. So those two chords are going to be congruent if this is true. So if we have the center, those chords have to be the same length. So those are the same length from the center. Then what happens is this chord here is the same length as this chord here. So we can put double tick marks on those. All right, so now that we've got some background knowledge, let's go ahead and jump into 2 more examples to finish things up. The first example, based on those theorems, actually deals with that last theorem that we just looked at. So we have this going on. Notice that the length from U to C is 7. So this is 7. And the length from C to V is also 7. So since UC and CV are both 7, what we can do is set x plus 17 equal to 3x. And then, so that means this chord has to be the same length as this chord. So we can solve that by subtracting x from both sides. These cancel, and we get 17 equals 2x. So if we divide by 2, we'll get 8.5 for x. All right, not too bad. In our last example, this one is a little bit tricky. They are missing a piece of information, so go ahead and add this in. We also need to know CD equals 8, so that's actually a given there. So we're going to find the perimeter of OPBDQ, this 5-sided figure. If AB is congruent to BD, and those are both 6, so we know that AB, I'm going to use actually a different color here, AB is 6. So if AB is 6 and BD is also 6, and then notice P is actually perpendicular there, so that means this and this both have to be 3. And then we actually also know CD is 8, so this length over here is 8. And again, notice this is perpendicular, so these two are congruent, and both of those have to be 4. They also tell us OP is 4 as well, so this is 4 here, and OQ is 3. So O to Q is 3. And now we can use that to find the length of that perimeter. So the perimeter we can find by adding those 5 sides, 4, 3, the bottom is 6, and then we have another 4 and 3 on the side. And let's see, 4 and 3 is 7, plus 6 is 13, plus 7 again is 20. So we get a perimeter of 20. All right, thank you guys for watching. If you had any questions on those examples, you be sure to ask in the comment section down below, or you can come find me and I would be happy to explain any questions or concerns that you have. All right, we'll see you guys next time. Take care.